should be a parentheses here, and here, and here. Parentheses is missing everywhere. Okay, make sure you guys put parentheses in here. Alright, this is section 1. Okay, section 1 of the review. So let's take a look at this. They give us a graph and they want us to find the limit. Okay, let's start with an A. In A, they want you to find a limit as x goes to 1 from the left hand side. So you're coming from the left hand side, and here's my 1. Okay, you're coming from the left hand side. So what's happening to the curve? It's going down to negative infinity. So this is equal to negative infinity. And in this one, in B, f is, we're finding limit of f of x as we come from a right hand side of 1. So we're coming from the right hand side. What's happening to the curve? It's going to negative 2. So that's equal to negative 2. So this one here in C, it says find the limit as x goes to 1. That means these two values have to be the same. They're not the same. So we say limit does not exist. And of course, in the last one, D, okay, they want you to find f of 1. F of 1 is that value, and that turns out to be negative 8. And that's it. This is problem number 2, okay, in section 1. Right, so let's go to problem number, let's go to section 3, problem number 2. Okay, so let me pause. Okay, this is section 3. So we're looking at section 3, and this is problem number 2. They want us to, they give us a piecewise function, okay, and they want to know if f of x, and there should be parentheses there, is continuous at x is equal to 1. If not, why? And what type of discontinuity do you have? Well, you can have different discontinuities. So one is when you have a curve like this, that's known as a removable discontinuity. Okay, and then non-removable discontinuity occurs when the curve does that. So you can't attach them. So removal means you can fill in one point and this becomes continuous. Non-removable, it doesn't matter. You can't fill anything in. You have to actually move the curve. So non-removable, in non-removable, this is known as the jump. Okay, and then you can also have non-removable where you have an asymptote. Okay, and then this is known as infinite. Okay, so both of these are non-removable when you have vertical asymptote or when the curve jumps from one point to the other. So you could also have a curve that can jump to, you have one like that, and that's known also as a jump discontinuity. Okay, so let's figure out what kind of discontinuity this is. They don't give us a graph, so we're doing this without the graph. Okay. Alright. So we're looking at discontinuity at 1. So this function is a line to the left of 1, and it's a parabola to the right of 1. And at 1 is equal to, at 1, there's going to be a point at 0. So basically, if you call that 1, so you're going to have that point. And then to the left of 1, and we'll call this x on the y-axis. Okay, the left of 1, you have this line. So this is going to be a line to the left of 1. And then to the right of 1, we're going to have a parabola. So what we need to know is it connected or not? So we have to find the limit. Okay, so let's find limit as x goes to 1 from the left hand side. So that one I have to use 2x plus 1. So when I use 2x plus 1, I'm going to plug in actual 1 right there. So when I put in 1 right there, that's going to give me 2 plus 1, which is equal to 3. And then limit as x goes to 1 from the right hand side, I have to check that also, x squared plus 2. So when I put in 1 right there, that's going to give me 3. So what this means is the curve, okay, goes to 3 from the left, and the curve goes to 3 from the right, but actually at 1 itself, it's a 0. So that means you're going to have we're not graph, it didn't ask us to graph. So let's call this 3. So you have a line, okay, so it goes at 1, it's going to become that, because you have a line with a positive slope. And then from there you have a parabola that opens up, okay, so it looks something like that. To the right of 1 you have a parabola, to the left of 1, and then at 1 itself it's going to be 0. So this is known as a removable discontinuity, because if you can just take this point and put it right there, it will get connected and be continuous. Okay, it's a removable discontinuity. Okay, so that's, let me pause again. Alright, now back. This is section number 5 and problem number 4. In this, they want me to determine the intervals which f is continuous. Okay, so first of all, let's look at this graph. This is a horizontal line at -2 to the left of -1, and then between -1 and 1 it looks like a B, and then to the right of 1 is going to be a parabola. Okay, now what we need to know is it where is this discontinuous? Well, the horizontal line is continuous. Even a V graph is continuous. Okay, parabola is continuous. So only place it could be discontinuous when they change behavior. So we're going to look at the limit of this at x is equal to -1, because that's where it changes behavior. And then we're going to look at the limit of this function, piecewise function, x is equal to 1, and also changes behavior. Okay, so at -1 it changes from a horizontal line, okay, which is that, to a V. Okay, so let's find the limit as x goes to -1, and we're going to use -2, so that's left of -1, so that's equal to -2. Okay, and f of -1, we're going to use the same thing, that's also equal to -2. Okay, now we have to have 3 things happen here, so we've got to find the limit as x goes to -1, and this is, I'm sorry, this is from the left hand side. -1, this is from the right hand side. Okay, and that means we have to use absolute value of x. Okay, when I put in -1 right there, that becomes +1. So they're not connected. These 3 things here have to be the same. Okay, they're not connected. Alright, so we know it's discontinuous. Okay, right now it's discontinuous at x is equal to -1. Okay, we know that. Okay, now let's check at 1. So we're going to take a limit as x goes to +1 from the left hand side, which is the absolute value function. So absolute value of x, which is going to turn into, when I put in 1, that turns into 1. And let's go ahead and find what is f of 1. Well, that one I have to use bx squared, because that's where x is equal to 1. So that would be 1 squared, which is 1. So far so good. 2 of them match up. Now we have to take a limit of this from the right hand side, limit as x goes to 1 from the right side. Well, for that one we're using a parabola, because parabola is to the right of 1. So x squared. Okay, now I'm going to plug in 1. Okay, so that means that turns into 1 too. So that means this thing is continuous at 1. So the only place is discontinuous, okay, is at x is equal to -1. So that means the question is determine the intervals which f is continuous. So we can say f of x is continuous from -infinity to -1, okay, and the union of -1 to positive infinity. So it's continuous everywhere else. Okay, so that's the only place it's discontinuous. Alright, let me pause it again. Okay, now I'm back. So we're finding limits. This is section 6 and section 7, section 6/7. Okay, let me do a few of these problems. Okay, let me do 4 in section 6. Okay, let's start you off with. Now, we found limits of this. So this is limit as x goes to 3, have x to the second minus 9, all that over x to the second minus 6x plus 9. Of course, the old school way is when you plug in 3, this top turns into 0. When you plug in 3 here also, that becomes a 9 minus 18 plus 9. That turns into 0. So I have a 0 over 0. I got a 0 on the top and I got a 0 on the bottom. Okay, so I can't take a limit. So I have to do some algebra. So I'm going to show you the old school way, doing some algebra, and then I'm going to show you what's called a L'Hopital's rule. Okay, so now the old school way is to factor this. So the limit as x goes to 3, I have an x minus 3 times x plus 3, and then the bottom I need to factor that. I'm looking for x factors of 9, so it'll be x minus 3 times x minus 3. Okay, they cancel. Okay, and then I'm going to have a limit as x goes to 3. Okay, x goes to 3. I have x plus 3, all that over x minus 3. Okay, so now I'm going to plug in 3. So I'm getting 0 on the bottom, but I'm getting a 6 on the top. So we know limit does not exist. Well, we can also, if we want to be a little more specific, okay, what we can do is we can take limit from both sides, okay, and see if it goes to positive or negative infinity. So x goes to 3 from the left side, x plus 3, all that over x minus 3. I can't plug in 3. I'm going to plug into the left of 3, which is 2.99999. Okay, the top is going to go to 2.99999. It's going to give me a positive number. And then the bottom is going to be very small negative. So this is going to go to negative infinity. And then we're going to plug in limit as x goes to 3 from the right side. Okay, and that is going to give me x plus 3 over x minus 3. I'm going to plug in 3.01. Okay, that's going to give me a positive number again. And then in the bottom, when I put in 3.001, something like that, I'm going to get a very small positive, and it's going to go to positive infinity. Of course, it goes to two different places, so we can say limit does not exist. Alright, so here's the L'Hopital's rule. Okay, so now I'm going to teach you the L'Hopital's rule. Okay, instead of doing all that algebra work, we can also use the derivatives. Okay, so to find the limits. Okay, first of all, you got to remember a couple of the rules. Okay, first, there's many situations where you can use L'Hopital's rule, but you can use L'Hopital's rule when you get a 0 over 0, or when you get infinity over infinity. And down the road, in BC Calculus, we'll show you how to find other situations where you can use L'Hopital's rule. Okay, so this is L'Hopital's rule, the hospital's rule. Okay, so since clearly this went to 0 over 0, so what L'Hopital's rule says is, if you get a 0 over 0 infinity over infinity, and that's all you need to know for AB calculus, okay, we can take this function, which is x squared minus 9, all that over x squared minus 6x plus 9, and then we can take a derivative of this function, Now, we're not using the quotient rule, so be careful. So we're going to take the derivative of the top, okay, which is going to give me 2x, all that over. We're going to take the derivative of the bottom, which is 2x minus 6, and then we're going to plug in 3. So we're going to, when we plug in 3, we're going to get a 6 on the top, okay, and we're going to get 0 on the bottom, so we know limit does not exist. Okay, originally we had 0 over 0, okay, so we just take the derivative of the top, derivative of the bottom, plug it in. Now, let's do number 5 using L'Hopital's rule. Limit as x goes to 2. First I have to establish I'm going to get 0 over 0 or infinity over infinity. Okay, as you can see, when I plug in 2, I'm going to get a 0 on the top. When I plug in 2 there, I'm going to get 0 on the bottom, so I can use L'Hopital's rule instead of factoring. Most of you probably don't even know how to factor difference of 2 cubes anyway. Okay, so here it is. Limit as x goes to 2. When I take the derivative of that, I'm going to get 3x squared. And then I'm going to take the derivative of the bottom, which is going to give me 2x. Okay, and then I'm going to plug in. Now, if I get 0, 0, I can keep doing L'Hopital's rule until I don't get 0, 0 or infinity over infinity. Okay, I can keep doing L'Hopital's rule over and over again until I don't get one of those. So in this situation, I can see I'm not going to get 0 over 0. Okay, when I plug in 2, this turns into 3 times 4. Okay, on the top, when I plug in 2, is 2 times 2. Okay, which is a 12 over 4, which is equal to a 3, and there it is. So limit of this function turns out to be 3 using L'Hopital's rule. Okay, that's equal to 3. Alright, now let's do a couple of these problems. There's parentheses missing here, here. There's let's see, there's parentheses missing here, here, and here. So it didn't show up on the worksheet, so make sure you guys put those parentheses in. Right, so let's do these two problems. Now this has nothing to do with L'Hopital's rule, but you can use L'Hopital's rule. Okay, so let me clear this out. Alright, so get back to this, number 6. So number 6 looks like it's a limit, and it shows up on the AP test. So if it shows up in the AP test, you know it's going to show up on the midterm. Delta x goes to 0. Okay, x plus delta x to the 5th, okay, minus x to the 5th, all that over delta x. Okay, so it might look like you're taking a limit of this, but remember that if f of x is equal to x to the 5th, okay, not 3rd, 5th, is x to the 5th, okay, and if I ask you to find the derivative of this function, okay, oh, come on, okay, alright, get back to this. Okay, if I ask you to find the derivative of this function the long way, then you use the derivative formula. F prime of x is equal to limit as delta x goes to 0, okay, f of x plus delta x minus f of x, all that over delta x. Okay, that's what you would use. And when you plug it in, okay, this will look like limit as delta x goes to 0. When I go find that, I'm going to put in x plus delta x, so x plus delta x is going to be to the 5th power minus f of x, which is x to the 5th, all that over delta x. Look, this is exactly the same thing as what they're giving us. So all we have to do is, you can do it the long way, and you've done it that way before, But if you know what they're talking about, this is really definition of a derivative, and the function is located right there, then you don't have to use limits. So what they're really asking you is, when they give you this on the AP test, which will be on the multiple choice portion of the test, it's easy. Okay, they're just telling you f of x is equal to x to the fifth, and they want you to find f prime of x, which is 5x to the fourth. And that's it. That's done. Okay? So they're not really asking you to find the limit here. Well, they are, but they're trying to see if you know the definition of a derivative. That's what that is. Okay, now let's do number 8. Okay, and there might be, I think I want to do number 8 and 10. Okay, so all right. So let's look at number 8. Number 8, they have a limit as h goes to 0. Okay, sine of 2x plus h. Okay, and that's where the parentheses should be. Sorry about that. Let me rewrite that. Okay, that will be 2. Okay, it'll be 2 times x plus h, okay, minus sine of 2x, all that over h. So I should erase, oops, that's not good. Backspace that. Okay, so instead of, let's put parentheses here and here. So this parentheses doesn't belong there. Okay. So this is what we have. It's what we have. Okay. Now all that over h. So again, this is a definition of a derivative. Where is my f of x located? Okay, f of x is located right there. Okay. So that's sine of 2x. And what do they want me to find? They want me to find f prime of x. Of course we can do it the long way. Or we can actually take the derivatives, which is cosine of 2x times 2, and then you're done. Okay. All right. Like I said, I want to do number 10 also. It's kind of unique. So 10, limit as x goes to pi over 4. Okay. Tangent squared x minus 1, all that over x minus pi over 4. Alright, this is an alternate definition of a derivative. So far we know f prime of x is equal to limit as h goes to 0, f of x plus h minus f of x, all that over h. Okay, we have that definition. But there's also a second definition we had in the textbook, and that is limit as x goes to some value a, okay, and that is going to be f of x minus f of a, all that over x minus a. That means as x gets closer to a, that's the change in x, and that's change in y. Okay, then this gives us also a derivative. Okay, so this is number 10 is stated in this format. So what they're really asking you is they want you to find the derivative of a function at some value a. So first of all, where is the function? Function is located right there. So my function is f of x is equal to tangent squared x. And they want you to take the derivative of that, so let's go ahead and take the derivative of this. We have to use a chain rule for this one. So outermost function is 2, so it'd be 2 tan x times the derivative of tangent, which is secant squared x. And then what they want you to do is they want you to find the derivative at that particular value. So f prime of pi over 4 turns out to be 2 tangent of pi over 4 times secant. Well, so what is secant? Secant is really cosine, 1 over cosine. So let's go ahead and write this as 1 over cosine, okay, pi over 4, and then we're going to square that. Alright, so let's go over here, find out what that is. That's equal to tangent of pi over 4 is 1. So it'd be 2 times 1 times, what's cosine of pi over 4? Cosine of pi over 4 is rad 2 over 2. So rad 2 over 2, and we're going to square that. Okay, so this becomes 2 times, when you flip that, that'll become 2 over rad 2, and we're still squaring that, which is 2 times, the top becomes 4, bottom becomes 2. Okay, so they cancel out, which is going to give me 4, and that's what that is. Okay, so it looks like we're taking a limit, or they're asking you to take a limit, okay, but they're not. They're really asking you to find derivative. And these type of problems do show up on the AP test multiple choice all the time. Right, so let's go to the last couple of examples. Again, we're going to jump back to L'Hopital's rule, okay, on finding limits of trig functions. So there's an easier way than what we did in the past. Okay, so from this point on, you're allowed to use L'Hopital's rule when you're finding limits if it's easier to do it. Sometimes it's just easier to just go through algebra. Alright, so you'll see how L'Hopital's rule is going to come in handy. Let's start with, this is section 7, and this is number 1. So we're going to find limit as x goes to 0, okay, sine of 4x over sine of 5x. Of course, in this one, this is what we use, limit as x goes to 0, sine of x over x. We're going to use that theorem, that's equal to 1, okay, and we're going to do some algebraic manipulations and whatnot. So that's what we did in the past. But now we're just going to plug in 0 first. When I plug in 0 for x, sine of 0 is 0. Now I plug in 0 for x here, I'm going to get 0. So as soon as I get 0 over 0, or infinity over infinity, okay, I can use L'Hopital's rule. So I'm just going to go limit as x goes to 0, derivative of sine of 4x is going to give me cosine of 4x times 4, all that over derivative of sine of 5. I'm not using quotient rule. Okay, this is called L'Hopital's rule. Sine of 5x is going to be cosine of 5x times 5. Okay, once I take a derivative, I'm going to plug in again. Okay, when I plug in 0, cosine of 0 is 1, so 1 times 4 is 4. And when I plug in 0 there, I'm going to get 1 times 5 is 5. That's 4 over 5. And that's done. Okay, using L'Hopital's rule. Alright, so let's do the second one, where I have a limit as x goes to 0 of x to the second minus 2x, all that over, okay, sine of 3x. Again, when I plug in 0 on the top, I'm going to get 0. When I plug in 0 on the bottom, I'm going to get 0. So when I get that, I can use L'Hopital. So I have to establish that first, okay? I can't just jump to L'Hopital's rule. If I don't get that, or infinity over infinity, I can't use L'Hopital's rule. Limit as x goes to 0. When we take the derivative of the top, I'm going to get 2x minus 2. When I take the derivative of the bottom, I'm going to get cosine of 3x times 3. Now we're going to put in 0. So when I put in 0 there, I'm going to turn in, it's going to turn into negative 2. When I put in 0 there, cosine of 0 is 1, so it's going to turn into 3, and there it is. That's the limit of that using L'Hopital's rule. Okay, alright, I want these notes turned in. Let me come back. Okay, that's it. So we are doing sections 1 through 7. So homework is sections 1 through 7. That's what I'm going to go over on Monday. Okay.